Do you really have You've Got Mail as a ringtone?
Just do. And that was Twitch telling me you're alive.
Huh. Let's see. This new one. All right, so today we're going to be doing a little segment called Cleaning Up Someone Else's Mess, and I'm making fun of this because this came from another store that did what I say no other store should do, which is try to fix everything themselves and send it here only when it's impossible. There's a reason for this. We have something called a no-fix, no-fee model. And no-fix, no-fee means if we can't figure it out, we don't charge you, which means that if you send us stuff that you've tried to repair, which means there's a lesser likelihood of it being fixed, or that you're only sending us the stuff that's completely impossible, that's kind of a dick thing to do, in my opinion. And damn, I need to put a Dogecoin in the swear jar now. So, and I think that that's kind of a douchey thing to do. And it's definitely something that's going to get you to the bottom of the pile. So this is a place that has complained because this has been here for a week and I have not even looked at it yet. And there's a very good reason that I haven't even looked at it yet, because it looks like this. So let's just plug it in so that you can get an idea of what it is we're looking at. So first thing you can see is the LCD connector has been replaced. Now, has this LCD connector been vetted to ensure that the pins are actually soldered to the board? Not really. They're barely soldered. Every single one of these pins is being held on there by, look at this. I can move it. I can move it. This is sad. This is, look, what is this? What is this? Why are you sending me this? Why do you have a license to be in business doing this? Why are you advertising to customers that you fix things when this is what you do to them? And it is okay if you screw up your own stuff. To be clear, I have no problem with you screwing up your own stuff. The issue is when you screw up other people's stuff when other people are paying you good money. Now, let's take a look at the rest of this board. Why is this not here? Why is this not here? Why is this missing? Why don't you put that back? Like, why does the BIOS chip have flux around it? Okay, I see that you've run wires in this area, and you've run wires for sensor issues, but why are you running wires for sensor issues when the board doesn't even have a brain yet? So this is silly. It's like focusing on someone's. We're gonna try our best to make sure that you have 20/20 vision while you're in a coma. The machine has no brain. So let's check this out. So when you turn it on, it's supposed to do a chime, right? So we're going to do a chime. We're gonna plug it in, see if we get a chime. The speaker is plugged in. He's going to turn on our power supply here. 5, 4, 3, 2, 1. No chime. So what does no chime mean? No chime typically means no CPU Vcore. And if we were to bring up the schematic and the board view, you'll see what this means. So we're just going to open up the schematic and the board view. And the reason I make fun of this business is because they're a business that they're doing that cheating lame-ass thing with Google, where their business name is a search term. So their business name is not an actual business name. Their business name is a search term. And for all the updates that they say they do to Google so that, people can't take advantage of this, for all the updates that are done to make sure that you only get the most high-quality search results, you can name your business name a search term, open up months ago, and show up #1 on Google, which is, again, kind of lame. Jessa says, I bet you let a student work on that board. Time for class action. Oh, yeah, for those of you who don't follow Jessa's stream, which, by the way, you all should, she has an excellent channel called iPad Rehab doing the same stuff we do, except on cell phones. What was going on with Jessa was she was getting emails from people that wanted to sue her because she said, I know why it took you so long to fix this phone. It couldn't be because I sent you something that was the worst in the pile. It couldn't be because investigative diagnostic repair at component level on a device this big with thousands of components takes time. It's because you save them for your students to save money. It was pretty funny. And I've always said that when a customer threatens to sue you, in my experience, that has always been complete BS and an over-exaggeration. And I imagine the same is true with Jessa. So if we were to get into the real issue here, let's go over something called CPU Vcore. Now, any of you who have ever overclocked a computer before know what CPU Vcore is. CPU Vcore is the voltage sent to the CPU to power it. And typically, if you're overclocking, you would raise CPU Vcore, so you have a little bit of an understanding. And CPU Vcore in this machine is controlled by U7400. And you can see over here, it says CPU Vcore regulator. And under it, you can see that this controls a buck converter. And to define a buck converter is going to be something that takes a higher voltage and turns it into a lower voltage. The way it does this is by cutting it up into pieces. So let's say we have 12 volts and we want to turn it to 1 volt. What we're going to do is we're going to take the 12 volts and send through a tiny spike. We're going to say, okay, here's some 12, but then nothing. And then here's some 12, and then nothing. And then here's some 12, and then nothing. And it's going to go back and forth between 12 and nothing. And that's going to average out to something like 1. But the CPU doesn't like that. The CPU is not going to like getting 12 and then 1 and 12 and 0 and 12 and 0 and 12 and 0. So we're going to put it through an inductor, which happens over here. You see L7510 is an inductor that's going to even out and smooth out the spikes. And then it's going to go to hundreds of little capacitors, which are going to be used to smooth out the line. And we should find that somewhere. There's going to be a page where you're going to see nothing but a bunch of capacitors on a line. I'll try to find that here. Mike Crackle, someone says. Oh, boy. Okay. Now I get it. 1 second. All right, so hopefully that sounds better. You let me know if you hear any crackling. Hopefully the crackling is done. Sounding better? Let's see. Anybody I can trust in the chat to give me an honest answer? TCRS, Jessa. Is it sounding better or still crackling? Miles, I trust you too. Miles, Jessa, what do you all think? All right. I can trust you guys who say it's a lot better. If something happened to the plug on my mic that I soldered on there, it has started to, the shield started to come off. So anyway, so if we were to scroll down, you'll see that PPV-Core SoCPU has hundreds of these little capacitors that are going to be used to smooth it out. So we're going to get a nice, even, easy breezy 1 volt. And U7400 is going to control this. So let's just go over the board and see on the schematic and the board view where it is we would find CPU Vcore. So it looks like this is a great spot to check it. So I'm going to turn it on, and we're going to check for CPU Vcore right here, PPV-Core SoCPU at C1680. So let's turn on the power supply and see what we get measured with voltage. And as you can all see, we get 0.00 volts. So 0.00 volts going to the CPU is going to give you a very similar effect as when you send 0 volts to the brain of the individual that tried to work on this, which is the brain is not going to work. And because the brain is not working, the brain is not turning on, the CPU is not turning on, we don't have something working. So now what we need to do is figure out why that is. So if we go over to stupid microphone thing. I got to get another 1/4 inch plug, one of these things to plug into my wireless thing. Boo. Here, let's see. What if I just... I'll put this in maybe in my pocket or something so it moves around less. Yeah, I'll put it on the chair so it moves around less. Hopefully that'll make it sound better. Anyway, so what we're going to do is check out what's going to cause something like this to happen. So let's open up this PDF. And the first thing that I would ask, or the first thing that I would address your attention to, is the fact that this chip is designed to be used on multiple different machines that have multiple different power rails. So U7400 is being used to have 12 volts be turned into 1 volt. But this same chip gets used on machines where they're trying to turn 8 volts into 1 volt. It's used on machines where they're trying to turn 15 volts into 1 volt. It's being used on the... So this chip needs to have some way of understanding how long it should be on for. So if we're trying to turn 12 volts into 1 volt, we're going to let through less spikes than we would if we were trying to turn 8 volts into 1 volt. And we would use less spikes to turn 8 volts into 1 volt than we would to turn 5 volts into 1 volt. It's just common sense that if we're doing averaging and we want to get 1 volt, and we're choosing between 12 and 0 and 12 and 0 or 8 and 0, that we would have more 8s and less 0s if we wanted to average out to 1 than we would if we were doing 12 and 0. So this chip needs some way to tell how often should I be on. And that's going to happen at something called the time on pin. So here you have CPU IMVP, so CPU voltage, TON, time on, ton, time on A and time on B. And here you're going to have a resistor that sits between time on and the main power rail, which over here is PP, VIN, CPU, SO, CPU IMVP, that is going to be used to create the CPU Vcore. So if we go to the second page, these transistors are doing the job of switching. These transistors are going to be switching up and down. So Q7510 is going to be switching PP-VIN CPU IMVP, which is 12.6 volts. It's going to be switching that. So sometimes you're going to get 12 volts going through, sometimes you get 0, sometimes 12, sometimes 0. So this is the main power rail that's going to be used to turn it into, that's going to be turned into CPU Vcore. Now, this needs to know how often to be on. If we have a higher voltage, it's going to have to be on less of the time to get to 1 volt. If it's a lower voltage, it's going to have to be on more often to get to 1 volt. So in order for U7400 to do the calculation to figure out how often does this transistor have to be on for us to get an average of 1 volt out of here, it needs to know what this power rail feeding the transistor is. And that is going to come through via PP, VIN, SO, CPU, IMVP, going into the time on pins. Now, if we were to take a look, PP, VIN, SO, CPU, IMVP, if we were to take a look at what's going to be feeding that R7403 and R7402 on the board view software, R7402 and R7403 are right over here. And I'm going to bring them up on the microscope so that you can see them. And as you can see, there is solder and there is flux in that area, indicating that someone did either replace them or touch it up, and there was some reflowing done in that area. And I'm going to show you why that is clearly mindless reflowing. So if we look, this is supposed to go to the chip, and those pathways seem to be okay. They seem to have been redone in some way. But the other side is supposed to go to PP bus S5 HS computing iSense, which I'm guessing is tied to PP VIN SO CPU IMVP. Let's just confirm that I'm not talking out of my rear end with that one. So if we go to the power aliases page, as you can see, PP bus S5HS computing iSense is also PP VIN SO CPU IMVP. So they're essentially the same thing. So these resistors for time on need to be attached. These need to be attached to this, right? Now let's just take a look under the microscope and see if that's what's going on. So if we zoom out on the microscope, you'll see that this entire section of the board is ripped off. And the only reason that I can imagine it's ripped off is because the person leaving this stuff off here is an idiot. So this needs to attach to this. And this is all, like, what is that? Well, that doesn't seem to be something that's attached. This seems to be something that got entirely ripped off of the board. So we're going to try and tin that and run a jumper wire and pray that that fixes our problem. And I also have to be reminded to buy myself one of those Sennheiser 1/8" adapters for this microphone so that it stops crackling all the time. Ugh. Maybe I also lost that little thing that allows it to... Let's see if I can find that. I have one of these little adapters that allows it to, like, you know, stay on your belt. Let's see, do I have another one of those? Here we go. Yeah, I'll just steal one of these things. Damn, that's stuck in there hard. What? Oh, it's beeping. Whoops. I've actually kind of learned to tune that out. Okay, my sissy hands aren't able to get that little plug off, so never mind. We'll solve that later. I'll just carry this thing around for the time being. So, this point over here on the right needs to get attached to these two resistors. So first thing I'm going to do, after that scraping is add a little bit of flux, because that's going to help the solder flow in that area. And then we have to run a wire to those resistors. And keep in mind, this doesn't have to be a really thick wire. We're not, again, these are 150 kilo ohm resistors. It's not like we're using a bunch of power here. It by no means needs to be something that's capable of handling large swaths of electricity. Hey, yeah, sorry about Crackle. I have to reball my microphone. All right, so that's connected. Now we're going to see if we have CPU Vcore when this turns on. Or if it blows up. It could always blow up. You never know. Now, the reason I'm doing that before touching up on the LCD connector and the other stuff that was taken off for no good reason is because I want to know if I'm wasting my time entirely by working on this, which I probably am, but I want to kind of gauge that. So we're going to measure CPU Vcore at those capacitors below where it shows up. Interesting. So we're still getting 0 volts. Let's see if we're at least getting the 12 volts that we're supposed to at these resistors. We're getting 1. So that's 1.35 volts. So this point that got ripped and destroyed off of the board is too destroyed for us to be getting any results there. So it looks like we're also getting the exact same signal from here. So I'm going to try running the wire differently. And this wire actually also just broke off as soon as I touched it. We're going to try running it from here, because this point over here is only getting 1.35 volts. Up here we would be getting something more, because that part of the board seems like it's still attached properly. We're just going to tin that up. We'll run another wire. And we'll rip that other one off in a short second. Let's get our tweezers to make that neater, to make that wire nice and flat. I'm going to solder it down here. Okay. Just going to get rid of the excess over there. And we're going to turn it on and see if we get any different results. This is how you repair motherboards, question mark. Yes, it is. Yes, it is. Okay. So now, let's get the multimeter back on the screen and measure the voltage at CPU Vcore down here and see what we get. And hopefully now we get a good result, since the CPU IMVP time on is going to be where it's supposed to be, 12 volt. And we get 0.00 volts. Well, that's interesting. Now let's just make sure that we're getting 12 volts here, like I think we're supposed to be getting. And we're getting 0. And there's 0 volts over here. Now this is really interesting at this point, because everywhere on the schematic and board view that it says this is supposed to be showing up, PP bus S5 8sense HS computing iSense, we're getting 0 volts. And we're supposed to be getting 12 there. So our issue at this point seems to be when this was ripped up, this is gone from all parts of the board. So now we have to figure out where this originated from. So the question now is going to be, where was this originated from? So PP bus, S5, HS, computing, iSense. So we're going to have to look that up over here and see where this originates, because apparently when that section got ripped off the board, something happened. Mark says, hi, I'm Mark from the UK. I like to watch all your videos. Well, thank you for the £5. I really appreciate that. That makes doing this miserable stuff slightly better. So we're going to find where that comes from. And it seems like, what? Why is it only showing here? Why is it only showing here? Surely that has to show up somewhere else. That's BS. That's total B. All right, let's just try shortening it a little bit. Okay, so it looks like R5410 is sitting between PP bus G3 hot and PP bus S5 HS, whatever the. So let's take a look at R5410. Where would we find that? So it seems that R5410 is a current sense resistor where this goes in and that goes out. And PP VIN S5 HS other iSense is actually going to be PP bus G3 hot. We're going to continue down the rabbit hole here and just to see if this is even remotely fixable before firing this person as a customer entirely. So let's take a look back at our board view software and find R5410. Now, R5410 is going to be on the other side of the board, so let's just take the board out of the machine and go from there. Where do you get these schematics? I get these schematics from the internet. The internet. So, the internet is a crazy place. I actually talked a bit about that on Pennsylvania Public Radio. Somebody came to interview us yesterday. Very nice person. Now, if we look, you'll see that there is a resistor that has a bunch of wires going to it, and these wires are all not shielded at all, and they're going over other probe points because, you know, because, well, who the heck knows. So let's work on figuring out that mess. So that's all for the sensor issues. And of course, we must solve sensor issues before getting the machine to boot. That's totally the right order within which to work on this. So let's see if what we're getting on each side of that resistor. Because we want to track down where PP bus S5 HS other iSense went missing, because it's missing from the rest of the board. So let's check here. And it looks like we get 12.6 volts on this side and 12.6 volts on that side, which means that I'm going to have to attach a wire between there and this point up here, because it's missing entirely from this section of the board due to these completely ripped out sections that were ripped out because idiocy. Again, how do you do this? How do you have a license for a business and do this? How? Why? What is this? What is this? This is not necessary. This isn't even long screw. I mean, on an iPhone, you would be you could get long screw damage, and I get it. Maybe you put the wrong screw in the wrong hole. It happens every now and then, and fine. But how do you do this? I don't get it. So anyway, we're going to run this a wire up there. So we're going to have to run the wire from the left side. That's the side that's going to be PP bus S5 HS other iSense. And we're going to run that wire around the board over to where it's missing. And again, it doesn't have to be the thickest wire in the world. It doesn't have to be a thick wire. It's really not going to be used for much of anything. I also want to be careful not to screw up any of this wiring over here that's already existing. And okay, add a little bit of flux to make it nice. Oh, thank you, Anto Bjork, for the nice comment in the Twitch chat. I appreciate that. Okay, so we've got the wire tinned. Now I'm just going to grab it by the tweezer So we're going to grab it by the tweezer. When you're as good at board repair as I am, they let you do anything. Grab them by the tweezer. And we're going to run that up here. And we're going to make a couple of stops. The wire is going to make a few stops. And of course, it's going to be shielded along those stops because we're not idiots. So that wire is going to go to each of the places that I expect the Pepe Bus S5H high side computing iSense to be on this board where it wasn't. And its first stop is going to be over here. And its second stop is going to be over here. Get that other tangled, messy wire out of there. Hello, Vladimir. People, also, if you can do me a favor, since I'm very forgetful, please remind me to buy a replacement plug for my DPA microphone. Solderable Sennheiser 1/8" plug, since I know I'll forget. You can get rid of this crackling. And one of those little mounts for it to go on your waist. I miss being able to have a belt buckle with it. So, that's all set and done. So now we're going to turn it on and see if we get CPU Vcore, and I really hope we do after all this work. Because if we don't, then it's time to start calling it quits. So it's turned on, multimeter's on. We're going to go to the area where we would expect CPU Vcore to show up, and really? Still nothing. Okay, let's see. Are you turning on? Where is fan connector? Fan connector here. Yeah, you are turning on because we get 5 volts at the fan connector. Alright, so are we getting 12 volts over here after running that wire? And now this is genuinely interesting. It says 0. So this wire just... damn. Okay. Admittedly, I did something stupid when I ran the wire. It broke. I pulled it a little too hard. Alright. Can't call out other people for being dumb when I do something dumb now, can I? So, that was dumb. That was incredibly dumb. I should, for this wire, perhaps I should be using something a little longer. I mean, a little wider. You definitely need a wider wire. So I'm going to grab some higher gauge stuff that may be just a little bit more durable for that run. Okay. All right. Let's do this. Let's do this again. This wire is a little bit thicker this time. There's also the chance that this section of the board is actually shorted to ground. If that's the case, then this is just a complete and utter waste. Let's just check that first, because that would be funny. Vladimir made a very good point that could potentially just be working as a fuse. Because if this section of the board is shorted to ground as a result of the idiocy of ripping up pads, then we're done. And it looks like it is. So that section of the board is actually indeed shorted to ground. So I think that this is about, let's see. So this may all actually be shorted to ground as a result of somebody ripping layers out of the board. And if that's the case, then I'm taking this and the other 4 machines that this jackass dropped off and shoving them in the, and just telling them to pick this shit up and don't come back. So let's see if that's the case. So are the inputs to my CPU IMVP ton resistor shorted to ground? Okay, so they're not. So the pathway that would usually be for them is. So all of this section over here is shorted to ground. So there's a chance that this board is... I don't get why you don't cover the entire board in liquid metal instead of running these wires. That would make sense. All right, so it seems that this section is shorted to ground. There is no hope here. So what I need to do is I need to bypass this by running the wire directly to these 2 resistors, which is what we're going to do now, since I don't see... So you're right, that wire was not broken by me. That wire was broken by the fact that that section of the board was shorted to ground. So we're going to rerun this, and we're just going to run it directly here. We're not going to try to fix the paths because the paths are broken for a reason. Hi, I love watching your video. Damn it, that disappeared really fast. I can't see. Yeah. Let's see. Let me read that. Coins in the Doge jar. Yeah, I gotta put some coins in the Doge jar. I don't think I'm probing the wrong pad. Seems like that's... Let's see. I love watching your videos. They help me sleep. Keep doing what you're doing. Did you also hear about the new meme? Do you know the way? It's really funny. Okay, I haven't seen that. Thank you for the 5. Okay, so now we're gonna see. We're going to try and put the right wire in the right place. And hopefully it doesn't burn this time. I'm going to try grabbing the wire by the tweezer rather than by grabbing it by my hand this time. This is painful. Okay, that wire's there. Now we're going to run it where it's supposed to be. And we've already checked that that set of resistors is not shorted to ground. So where we ran the wire to before was. This is not. So I should be able to safely run this wire without having to worry about it breaking as a result of being used as a fuse. Okay, we've got that. Rip off the excess. Grab it by the... Okay. Now let's run this. Take 4. Okay, we're going to go back to where CPU Vcore should be. Get on that multimeter. Plug in my power R, and get to measuring. CPU Vcore. Okay, I think we got CPU Vcore because the power supply says we're using 0.2 amps more than we were before. And it looks like, oh, duh, turn it to voltage mode. Dumb. And it looks like we are getting 0.829 volts at CPU Vcore. So problem 1 has been solved. CPU Vcore works, the brain of the computer works, which is more than I can say for the original tech. Now, the next set of problems we're going to have to solve is related to no image. Well, you may say, how do you know you're not going to have an image? Well, that's a good question. The first way that I know that we're not going to have an image is that the IC responsible for powering the screen is not on the board. And the second way I know we're not going to have a screen is that this pathetic attempt at replacing an LCD connector is not even soldered. Again, this is not soldered. Like, Again, if you're trying to do this on your own machine, I would never, ever make fun of you. But if you are a business that purports to be charging money to do this under the guise of being an expert at it, then this is utterly shameful and despicable. And why customers do not trust people that work at repair stores or handymen or plumbers or electricians or mechanics. It's because of junk like this. This is why customers have no respect for this as a business. So we're going to try and make this great again. Ah, now that is great. Look at that. Look at that. Beautiful pads. Look at those beautiful tampons. I mean maxi pads. I mean, oh crap. Oh no. All the feminists that came after Linus are going to come after me now. Poor Linus. Poor guy. Poor Linus. I feel bad for him for that. I don't think he had even the slightest clue that was going to be the reaction to what he said. Here's my contribution to your success, Lewis. Your content has made a positive difference in my life, and I want to thank you. I'll be sending you a MacBook to fix at some point, says Tyrannosaur. Thank you very much. That is very kind. Hopefully you'll be able to fix your own MacBook from the stuff in these videos and maybe save some money. Okay, so we're going to find a new one of these ICs and put it there. Do you have certification for replacing LCD connector? I do not have certification for replacing LCD connector. Oh, that's the ultrasonic, by the way. Okay, have some ASMR. Doesn't that ultrasonic sound nice? All right, so now the fun is going to be finding a board that still has U9000 on it. Lol. This board still has U9000 on. What do you think the chances are we're going to have a working image circuit? What are your guesses? I was watching this one channel that I think many people will find funny called Freedom Tunes. And I think that's what's going to be what fixes this. Like every generation appears to laugh or think what the last generation did is ridiculous. And I remember growing up with my generation. I remember what it was like, and I just never imagined that our generation would be the generation to do things like what it did to Linus over him doing a video about the Amazon store. But I genuinely think the next generation is going to look at all this shit and just laugh and laugh and laugh. And I think that's going to be how this is all fixed. Freedom Tunes has some really funny stuff. Like getting kids engaged, you know, on the level of laughing at it, I think is what's going to fix it. So, okay, so we've got our pins soldered. We have our replacement IC on there, and we're just going to make sure that little trace nice and pretty. We're going to do the tweezer test on each of the pins to make sure that all the pins are soldered to the board. Not that I need to, because we do such perfect soldering here. Such perfect Victorian soldering. And we're going to see if we get a picture now on this complete pile of garbage. So, what do you all think? What do you all think is going to happen? You think it's going to work? Think it's going to be amazing? Or you think it's going to be dead? I think it's going to be amazing. I think that here we have the power to bring back even the most abused little boards that didn't deserve it. You poor little 3115. Show me where the bad man touched you, Mr. 3115. We'll make it better. We will make it better. Okay. So it's plugged in. Turning on. And we have a light on the screen. See? You have a light on the screen. It's gray. It's going to turn to a question mark soon. I'm not going to keep it on long enough for that because I didn't connect the heatsink because it didn't come with a heatsink. Actually, maybe I will leave it on for the question mark to come on. You didn't give it to me with a heatsink. I guess you don't want me to test it with one. That's the only assumption that I can make here. And we get a question mark folder, which means this poor, abused, raped, beaten, and battered little board has been made great again. That's what we do here at Rossmann Repair Group. If you want to watch more videos just like this one, you can check out the playlist on our channel, component level board repairs, and also live stream board repairs. We have another 600 repairs just like this. If you want to buy the tools that we use, you can check out this little advertisement below and go to that site. If you want to know how, if you're in the business of doing this and you're just a little bit confused, you've made your way through some of it, you have a pile of boards, and you just want some questions answered quickly, we have a forum that you could check out at rossmanngroup.com/boards, $29 a month to have an engineer answer all of your questions. That's it for today. Thank you for learning, and thank you for watching. And as always, I hope you learned something. And to the place that did this, I hope you go out of business.